Hello, dear children. You might have heard this statement. To every action, there is an equal and opposite reaction. This is Newton's third law of motion. You have seen birds fly, fishes swim, rocket moves. All these are examples or the applications of Newton's third law of motion. So, what do you mean by action and reaction? When our two bodies interact with each other, the force exerted by the first body on the second body is called action, and the force exerted by the second body on the first body is called reaction. And always this action and reaction are equal and opposite. Let us take an example. When we place a wooden block on the ground, this block exerts a force equal to its weight. What is weight? Weight is equal to mass into gravity, that is mg, acting downward to the ground. So this block exerts a force downward to the ground. So this is the action force. And the ground exerts an equal and opposite force, that is W is equal to mg, on the block in the upward direction. This is reaction force. Hope you understood what is action and reaction. So, these forces are having equal magnitude, but they act in opposite direction. Understood? So, it must be always remembered, the action and reaction always acts on different objects. That is, the third law of motion indicates that when one object exerts a force on another object, the second object instantaneously, that is at the same time, exerts a force back on the first object. Okay? There are a lot of applications of Newton's third law of motion. As I have said in the beginning, propulsion of fish through water is an example of action-reaction pair. A fish makes use of the fins to push water backward. This push serves to accelerate the fish forward. The flight of the bird is another example of action-reaction pair. The wings of the bird pushes the air downward. And what is the reaction? The birds could able to fly. Another example is recoil of gun. Have you heard about recoil of gun? A gun recoil when a bullet is fired from it. When a bullet is fired from a gun, the gun exerts a force on the bullet in the forward direction. Understand? So this is the action force. That is, when a bullet is fired from the gun exerts a force on the bullet in the forward direction. That is action force, and the bullet also exerts an equal force on the gun in the backward direction. That is why the gun moves a little backward, but see, this is the reaction force, but due to the larger mass of the gun, it moves only a little distance backward. And if you just keep it on the shoulder, then this will be giving a jerk at the shoulder of the shooter or the gunman. Okay. This backward movement of the gun is called a recoil of the gun. See, the Newton's third law of motion is very much related to our day-to-day activity. Even when a person is walking, when a person walks on the ground, he pushes the ground with his foot in the backward direction by pressing the ground. This push is known as the action. And Opposite reaction acts on the foot of the person by the ground. This is a reaction. When you jump, your legs apply a force on the ground, and the ground applies an equal and opposite reaction force that propels you into the air. Okay, so when you jump, when you walk, all these time this reaction process happens. While drawing a boat, when you want to move forward on a boat, you paddle by pushing the water backward, causing you to move forward. The same thing is happening while swimming. While swimming, a swimmer pushes the water backward with his hands. That is what is the action, and what is the reaction? The reaction offered by the water to the swimmer pushes him forward. This is the reaction. When a person jumps out of a boat, what will happen? He pushes the boat in the backward direction, and the boat exerts an equal force on the person in the forward direction. So when a person jumps out of a boat, the boat moves backward. So here also there is action and reaction. And as I have already said, motion of the rocket. In a rocket, burning fuel creates a push on the front of the rocket, pushing it forward. This creates an equal and opposite push on the exhaust gas backward. As you can see it here in the video, the rocket expels a hot gas with a large speed in the downward direction from the bottom end or the rear end. Okay. And an equal and opposite reaction acting on the rocket pushes the rocket in the upward direction. As I have said earlier, the forces are equal in magnitude but acting in opposite direction, and it acts on different objects. So they do not cancel each other. If the force is acting on the same object, they cancel each other because they are equal in magnitude and in opposite direction. But here the force acting is on different objects, so they do not cancel each other. So we can say that Newton's third law of motion describes the relationship between force of interaction between two objects. If an object A exerts a force on an object B, then the object B must exert a force of equal magnitude and opposite direction back on object A. So when we say the mathematical representation of Newton's third law of motion, we can say that let A be the body exerting a force F on the body B, then the body B too exerts a force which is in the opposite direction. So we can say that it is minus F on a body A, which is given as FAB. Because force is a vector quantity, we have to put the vector notation FAB, that is force exerted by a body A on the body B, that is FAB, is equal to minus FBA, that is force exerted by B on A. FAB means a force exerted by A on B, and FBA means force exerted by B on A. That will be equal and direction will be opposite. That is why minus sign. Hope you all understood this. Thank you.